Welcome to Deep Sleep Physics. I hope you're doing well and that you're ready to find some peace tonight. It's a pleasure to be your guide through the mysteries of the dark. Tonight, the journey moves far beyond the atmosphere of our small blue planet into the vast and silent ocean of space. From the surface of Earth, the universe appears calm, distant stars resting quietly across the night sky. Yet beyond the thin veil of our atmosphere, the laws that govern reality begin to behave in ways that feel almost unfamiliar. Space is not simply empty darkness. It is a place where gravity bends light, where time itself can stretch, and where enormous cosmic structures move slowly through an almost unimaginable scale. Even the concept of direction becomes strange in space. There is no true up, no true down, only motion, and the quiet pull of gravity shaping the paths of planets, stars, and entire galaxies. On Earth, gravity feels constant, holding oceans to the surface, guiding falling leaves toward the ground, keeping every object connected to the planet beneath our feet. But in space, gravity becomes something far more subtle, something that stretches across enormous distances. The Moon orbits the Earth, not because it is being pulled like an object on a rope, but because it is constantly falling, endlessly falling around our planet, moving forward through space while gravity gently curves its path. This same invisible force extends much farther than the Earth and Moon, reaching across the solar system, guiding planets in their long, patient orbits around the Sun, each world moving through space with quiet precision. Mercury circles the Sun in just a few short months, while distant Neptune takes more than a century to complete its slow journey. Yet every orbit follows the same fundamental law: gravity shaping motion across billions of kilometers. But gravity does something even more mysterious, something first described by Albert Einstein in the early 20th century. According to modern physics, gravity is not simply a force pulling objects together. It is the bending of space itself. Massive objects like stars and planets curve the fabric of space-time around them, creating gentle slopes that smaller objects naturally follow. A planet does not orbit the Sun because it is pulled directly inward. It orbits because it is moving across curved space-time, sliding along the shape created by the Sun's immense mass. In this way, the solar system becomes something like a slow cosmic dance, every world following invisible paths carved into the structure of the universe itself. Yet even this is only the beginning, because deeper in space, the rules become even stranger. Black holes warp space-time so strongly that even light cannot escape. Neutron stars compress entire suns into objects the size of cities, and galaxies drift slowly through vast cosmic voids. The universe, calm and silent from afar, is filled with physics that stretches the imagination. And tonight, as the mind drifts gently into rest, the strange laws of space begin to unfold, one quiet mystery at a time, across the endless dark between the stars. As the journey continues outward, beyond the familiar orbit of Earth, the strange nature of space begins to reveal itself more clearly. The universe grows quieter, darker, and far larger than the human mind naturally expects. Distances in space are so immense that ordinary measurements lose their meaning. Kilometers and miles quickly become too small. Astronomers instead speak of light years, the distance that light itself can travel in a full year, moving at nearly 300,000 kilometers every second. Even at that incredible speed, light takes more than 8 minutes to reach Earth from the Sun, a short journey by cosmic standards. Yet the nearest star beyond our solar system lies more than 4 light years away, meaning the light we see from that distant sun began its journey long before many events on Earth ever occurred. Looking into the night sky is therefore a kind of quiet time travel. Every star seen above represents light that has been moving across space for years, decades, or even centuries before reaching human eyes. Some stars, shining faintly overhead, may no longer even exist, their light continuing its long voyage long after the star itself has faded. A reminder that the universe does not reveal itself in the present moment, but through signals sent across immense stretches of time. Space itself is also expanding, a discovery that transformed our understanding of the universe. Galaxies are not simply scattered motionless through the cosmos. They are drifting apart slowly, carried by the expansion of space itself. This expansion began billions of years ago, during the event known as the Big Bang, when the universe was once smaller, hotter, and far denser than it is today. Since that time, space has continued stretching outward in every direction. The farther a galaxy lies from Earth, the faster it appears to move away. Not because the galaxy is racing through space, but because the space between galaxies is slowly expanding. In this way, the universe resembles something like a slowly rising loaf of bread, where raisins embedded within the dough move farther apart as the bread expands. The raisins themselves remain mostly still, yet the distance between them grows. Even empty space is not truly empty. It contains faint traces of energy, invisible particles appearing and disappearing in tiny quantum fluctuations, a restless activity occurring constantly within what seems like complete silence. This strange quantum behavior suggests that space itself has structure, subtle fields and energies filling every region of the cosmos, even the darkest void between galaxies. And within this vast, expanding universe, gravity continues its quiet work, gathering matter into stars, stars into galaxies, and galaxies into enormous clusters stretching across hundreds of millions of light years. These cosmic structures move slowly, almost imperceptibly, yet over billions of years they reshape the architecture of the universe. The night sky above Earth appears still and timeless, yet beyond our atmosphere, space is alive with motion, expansion, gravity, and light traveling endlessly across unimaginable distances. And as the mind settles deeper into calm, these quiet movements of the cosmos continue, unfolding patiently through time, guided by the strange and beautiful physics of space, far beyond the small blue world where this journey began. As the mind continues drifting farther into the vast quiet of space, another strange truth about the universe begins to appear. The deeper one looks into the cosmos, the less solid reality begins to feel. On Earth, matter seems stable and familiar. Mountains remain where they stand. Oceans move slowly with the tides, and objects feel solid beneath the touch of a hand. Yet at the smallest scales of the universe, matter behaves in ways that feel almost impossible to imagine. Every atom, every grain of sand, every distant star is built from particles so small they cannot be seen directly. Particles that follow the unusual rules of quantum physics, a realm where certainty becomes less absolute. In this microscopic world, particles do not always behave like tiny, solid objects. Sometimes they behave more like waves, spreading through space in patterns of probability, appearing in one place, then another, guided by mathematical laws rather than visible motion. Electrons, for example, do not orbit the nucleus of an atom like miniature planets around a sun. Instead, they exist within regions of probability, invisible clouds describing where the particle might appear at any moment. This strange uncertainty does not remain confined to atoms alone. It forms the foundation of everything that exists, from the smallest molecule to the largest galaxy. Yet despite this underlying uncertainty, the universe still forms stable structures. Stars burn steadily for billions of years. Planets maintain their orbits. Galaxies rotate slowly through the darkness. Order emerges from strange rules, stability rising from the quiet dance of countless particles interacting across space and time. Even empty space itself behaves in unexpected ways. Quantum fields stretch through the entire universe, subtle energies that exist everywhere, even where no stars or planets are present. Within these fields, tiny fluctuations occur constantly, particles appearing briefly before disappearing again, a restless activity hidden beneath what appears to be perfect stillness. This means that the universe is never completely silent. Even the darkest void carries a faint background energy, a quiet whisper of physics unfolding continuously throughout the cosmos. And while these processes occur on unimaginably small scales, their influence reaches across the entire universe, shaping the formation of atoms, stars, and galaxies. From the smallest quantum particles to the largest cosmic structures, the universe follows laws that are both elegant and deeply mysterious. And as the mind drifts gently through these strange foundations of reality, the vast quiet of space begins to feel even more remarkable. A place where certainty softens, probabilities unfold, and the hidden mechanics of existence continue their silent work among the stars. And within this quiet structure of the universe, where particles move in delicate patterns and galaxies drift across immense distances, another strange property of space slowly begins to reveal itself: the nature of time itself. On Earth, time feels steady and predictable. Seconds pass one after another, days follow nights, and the movement of clocks appears constant and unchanging. Yet in the deeper understanding of physics, time is not quite as rigid as it seems. According to the theory of relativity, time is connected to space in a single fabric, often called spacetime, a vast structure where motion, gravity, and distance are woven together into the same cosmic framework. This means that time does not flow at exactly the same rate everywhere in the universe. Under certain conditions, time itself can slow down or pass more quickly depending on the environment in which it is measured. Near very massive objects, such as neutron stars or black holes, gravity becomes incredibly strong. So strong that it bends space-time dramatically. And within this curved region, time itself begins to behave differently. An observer standing far away from such an object would see clocks near that massive body moving more slowly, seconds stretching slightly longer than they would elsewhere. A quiet slowing of time caused purely by gravity. This effect, known as gravitational time dilation, has been measured even around our own planet. Clocks placed slightly higher above Earth's surface tick just a little faster than those closer to the ground, because gravity weakens with distance. The difference is incredibly small, almost imperceptible in everyday life, yet it reveals something profound about the structure of the universe. Time is not separate from space. It moves together with gravity and motion. Speed can also influence time. Objects traveling extremely fast through space experience time differently than those standing still. As velocity increases, time for the moving object begins to pass more slowly compared to the outside world. This phenomenon becomes noticeable only at extraordinary speeds. Speeds approaching the velocity of light, where the laws of relativity shape motion in ways that seem almost surreal. Astronauts orbiting Earth aboard spacecraft experience a very tiny version of this effect. Their clocks differ by fractions of a second compared with clocks on the planet below. Subtle proof that time itself bends slightly under motion and gravity. Across the universe, near distant stars, within the gravity wells of galaxies, and at the edge of black holes, time flows at countless different rates, shaped by the invisible geometry of space-time itself. And yet, within the quiet calm of the night sky, these differences unfold so slowly that the universe still appears serene. Stars shining gently across the darkness, galaxies drifting across billions of years. Within that immense stillness, space, gravity, and time continue their silent interaction, shaping the structure of reality itself, far beyond the small world where human clocks quietly count their seconds. And as time itself bends quietly within the fabric of space-time, another strange feature of the universe begins to emerge, something that cannot be seen directly, yet quietly shapes the motion of galaxies across the entire cosmos. For centuries, astronomers believed that the stars and visible matter in the universe accounted for nearly all of its mass. The glowing light of galaxies seemed to reveal the full structure of the cosmos. Yet careful observation slowly revealed something unexpected. When scientists began measuring how galaxies rotate, they discovered a quiet mystery. The outer regions of galaxies were moving far faster than expected, far too fast to be held together by the gravity of visible stars alone. According to ordinary physics, stars on the outer edges of a galaxy should drift away into space, their motion too rapid for the gravity of the galaxy to hold them in orbit. And yet, they remain bound together, rotating calmly around the galactic center. Something unseen, something silent, appears to provide the missing gravity. This mysterious substance is known as dark matter, an invisible form of matter that does not emit light, does not reflect light, and cannot be seen through telescopes. Yet its gravitational influence stretches across the universe. Galaxies seem to float within enormous halos of this unseen material, vast clouds of dark matter surrounding them like invisible structures holding their stars in place. Without dark matter, many galaxies would slowly unravel, their stars drifting away into the cosmic darkness. But with it, the great spiral structures of galaxies remain stable across billions of years. Even clusters of galaxies, enormous gatherings containing hundreds or thousands of galaxies, appear to be bound together by this same hidden substance. Through gravitational measurements, scientists have estimated that visible matter, the stars, planets, gas clouds, and dust we can observe, make up only a small fraction of the total matter in the universe. Most of the universe appears to exist in forms that cannot be seen directly, dark matter providing invisible structure, shaping the cosmic web that stretches across unimaginable distances. Enormous filaments of galaxies, clusters, and vast empty voids form a pattern sometimes called the large-scale structure of the universe, a delicate network shaped largely by the gravity of dark matter. And yet, despite decades of study, the true nature of dark matter remains unknown. Particles that have never been observed directly, moving silently through the cosmos, passing even through planets, stars, and galaxies without leaving visible traces. Across the vast darkness between galaxies, this invisible presence quietly holds the universe together, guiding the motion of stars, shaping the formation of galaxies, and influencing the evolution of cosmic structure. And as the mind drifts gently through these enormous, unseen frameworks, the universe begins to feel even more mysterious, a place where most of reality remains hidden, quietly guiding the dance of galaxies beneath the silent glow of distant stars. And within this immense cosmic structure shaped by dark matter, another quiet mystery begins to appear. Something even more unusual than invisible matter. A force that seems to push the universe itself apart. For most of human history, gravity was understood as the dominant force shaping the cosmos, drawing matter together, forming stars, galaxies, and the vast clusters that stretch across space. Gravity gathers, it pulls, it builds structure slowly over time. Yet when astronomers began studying the expansion of the universe in greater detail, they discovered something unexpected, something that seemed to move in the opposite direction of gravity. The expansion of the universe, first observed through the motion of distant galaxies, was not slowing down as many scientists had predicted. Instead, it appeared to be accelerating. Galaxies drifting away from one another faster and faster as time passed. This discovery revealed the presence of something deeply mysterious, a phenomenon now known as dark energy. Unlike dark matter, which gathers matter through gravity, dark energy appears to do the opposite. It gently pushes space itself outward, causing the expansion of the universe to grow gradually stronger over time. This energy is incredibly subtle, impossible to feel directly, yet it fills the entire universe, present even in the vast emptiness between galaxies. In fact, most of the cosmos may be composed of this strange, invisible energy, a quiet pressure embedded within the very fabric of space. When scientists measure the total content of the universe, they find that ordinary matter, the stars, planets, gas, and dust that form everything visible, make up only a small fraction of reality. Dark matter forms a larger portion, shaping galaxies through gravity. But even this mysterious substance is overshadowed by dark energy, which appears to dominate the large-scale behavior of the universe. Across billions of years, dark energy slowly stretches the distances between galaxies, expanding the cosmic landscape gradually, almost imperceptibly, yet with immense cumulative effect. Galaxies that are already distant from one another drift even farther apart. Vast regions of empty space widening slowly between the great islands of stars. Over unimaginable spans of time, this expansion will continue, the universe becoming larger, colder, and darker as galaxies spread farther across the cosmic horizon. And yet, within this quiet expansion, stars continue to shine, galaxies continue to rotate, and gravity continues its patient work within smaller regions of space. The universe becomes a balance between opposing tendencies, gravity drawing matter together, dark energy gently stretching the cosmic fabric outward. Within this silent tension, the structure of the universe slowly evolves, guided by forces that remain almost completely invisible, shaping the fate of everything that exists across the endless dark between the stars. And within this slowly expanding universe, where dark energy stretches the distances between galaxies, gravity continues to shape smaller regions of space with quiet persistence, gathering matter, forming stars, and giving birth to some of the most extraordinary objects in the cosmos. Among these objects, few are as strange as neutron stars. When a massive star reaches the end of its life, its internal balance between gravity and nuclear pressure begins to collapse. The star's core compresses inward under its own immense weight, shrinking rapidly in one of the most dramatic transformations in the universe. In the final moments of this collapse, the star explodes outward in a brilliant supernova, releasing enormous energy into surrounding space, while the core itself continues collapsing, becoming something incredibly dense. What remains is a neutron star, an object so compact that an entire sun's worth of mass is compressed into a sphere roughly the size of a city. The density of such an object is almost impossible to imagine. A single teaspoon of neutron star material would weigh billions of tons under Earth's gravity. Matter compressed so tightly that atoms themselves can no longer exist in their ordinary form. Within this extreme environment, protons and electrons merge together, forming neutrons packed closely side by side, creating a structure unlike anything found on our planet. Gravity at the surface of a neutron star is incredibly strong. So strong that a person standing there would feel a force many billions of times stronger than Earth's gravity, an environment far beyond anything life could experience. Yet despite their violent origins, neutron stars often become remarkably stable, spinning quietly through space for millions of years. Many of them rotate incredibly fast, completing a full rotation in just fractions of a second. Beams of radiation sweeping across space as they spin, creating objects known as pulsars. To distant observers, these beams appear as steady pulses of light, flashing rhythmically as the neutron star rotates, like cosmic lighthouses turning slowly in the darkness. Across the Milky Way galaxy, thousands of these strange remnants exist, silent, compact, spinning patiently across the ages. They are the collapsed hearts of once enormous stars, objects that once shone brightly across the galaxy, now transformed into incredibly dense spheres of matter. And within the quiet vastness of space, these neutron stars continue their slow rotations, carrying the memory of ancient stellar explosions, while the strange physics of extreme gravity unfolds silently around them. And while neutron stars represent some of the densest objects in the universe, gravity can shape matter into forms even more extreme. Deeper within the strange physics of space, another phenomenon appears. One where gravity becomes so powerful that the very structure of space-time begins to fold inward. These objects are known as black holes. They form when a star far more massive than our Sun reaches the final stage of its life. After exhausting the nuclear fuel that once held it stable, gravity begins pulling the star inward with unstoppable force. In many cases, this collapse triggers a supernova, a brilliant explosion that briefly outshines entire galaxies. Yet after the outer layers of the star are thrown outward, the core continues collapsing under its own weight. If the remaining core is massive enough, nothing can stop the collapse. Matter compresses further and further, gravity becoming stronger with every moment. Eventually, the collapsing mass becomes so dense that it creates a region of space where gravity grows overwhelming, a region where even light cannot escape. This boundary surrounding the black hole is called the event horizon, a quiet, invisible surface marking the point where escape becomes impossible. Beyond this horizon, space and time curve inward so strongly that all paths lead deeper into the gravitational well. To an outside observer, objects approaching a black hole appear to slow down dramatically, their motion stretching across time as they approach the horizon, light from the object becoming redder and dimmer as gravity bends the flow of time itself. Yet for the object falling inward, the experience would feel different, crossing the event horizon without noticing any sudden boundary, continuing deeper into the curved structure of space-time. Black holes are not cosmic vacuums pulling everything toward them. From a distance, their gravity behaves just like any other massive object. Planets could even orbit a black hole in stable paths if the conditions were right. Across the universe, black holes exist in many sizes. Some formed from individual stars, others millions or even billions of times more massive than the Sun. At the center of nearly every large galaxy, including our own Milky Way, a supermassive black hole rests quietly, shaping the motion of stars near the galactic core. Despite their name, black holes are not simply empty darkness. They are regions where gravity has reshaped space-time itself, where the familiar rules of motion and time become deeply altered. And across the silent depths of the cosmos, these hidden gravitational wells remain scattered among the stars, quiet, invisible, yet profoundly powerful, revealing just how strange the physics of space can become in the darkest corners of the universe. Far beyond the influence of individual stars and black holes, the universe begins to reveal its largest structures, enormous patterns that stretch across distances almost impossible to imagine. When astronomers observe the distribution of galaxies across deep space, they do not appear scattered randomly. Instead, they form vast filaments and clusters, delicate strands of matter stretching across the cosmos like a quiet cosmic web. These structures are shaped largely by gravity and dark matter, guiding the slow gathering of galaxies across billions of years. In some regions, Galaxies collect into massive clusters containing hundreds or even thousands of galaxies. Enormous systems bound together by gravity, slowly orbiting a shared center of mass across unimaginable spans of time. Between these clusters lie enormous empty regions known as cosmic voids, vast spaces where very few galaxies exist, silent expanses stretching across tens of millions of light years. If one could step far enough away from the universe to see its full structure, it might resemble a vast network of glowing threads, galaxies forming luminous filaments, surrounding dark cosmic oceans where almost nothing exists. This pattern did not appear suddenly. It formed slowly during the early history of the universe, when tiny fluctuations in matter began growing under the influence of gravity. Over billions of years, these slight variations expanded, gathering more matter, shaping the large-scale structure that astronomers observe today. Within these cosmic filaments, galaxies drift slowly, sometimes approaching one another, sometimes merging together over immense stretches of time. Galactic collisions are not violent in the way they might appear. Despite containing billions of stars, the vast distances between individual stars mean that direct collisions are extremely rare. Instead, galaxies pass through each other slowly, their shapes stretching and distorting under the influence of gravity, spiral arms bending, streams of stars forming long, luminous arcs across space. Over time, two galaxies may merge completely, forming a single, larger galaxy with a new structure and motion, a process that can take hundreds of millions of years to unfold. Our own Milky Way galaxy will eventually experience such an encounter, slowly approaching the neighboring Andromeda galaxy across the darkness of space, their paths guided by gravity across millions of years. Yet even within these enormous cosmic structures, motion remains slow and patient. Galaxies drifting gradually along invisible gravitational paths, their stars continuing to shine quietly across the darkness. Across the vast cosmic web, clusters, filaments, and voids together form the grand architecture of the universe, a structure so large that light itself takes hundreds of millions of years to travel between its distant regions. Within this immense and silent framework, galaxies continue their slow migrations through space, guided by gravity, shaped by dark matter, and surrounded by the quiet expansion of the universe itself. Within this immense cosmic web, where galaxies gather along delicate filaments of gravity, light itself begins to reveal another strange property of the universe, one that quietly demonstrates how space can bend and reshape the paths of everything traveling through it. Light normally moves in straight lines, crossing enormous distances through the darkness of space, carrying information from distant stars and galaxies toward the eyes of observers far away. Yet when light passes near massive objects, its path can curve gently under the influence of gravity. This effect is known as gravitational lensing. According to the structure of spacetime, massive objects like galaxies or clusters of galaxies bend the fabric of space around them. And when light from a more distant galaxy travels through this curved region, the light follows the curved geometry of space-time itself. To observers watching from Earth, the result can appear almost like a natural cosmic lens. Distant galaxies may appear stretched into long, glowing arcs, duplicated into multiple images, or distorted into delicate rings of light surrounding a massive object in the foreground. These rings are sometimes called Einstein rings, subtle circles of light formed when gravity bends light from a distant galaxy in nearly perfect symmetry. Gravitational lensing allows astronomers to observe objects that might otherwise remain hidden. Galaxies too distant or faint to detect directly can become visible when their light is magnified through the gravity of another galaxy. In some cases, these natural lenses reveal galaxies that existed billions of years ago, their ancient light traveling across nearly the entire age of the universe before reaching telescopes on Earth. The phenomenon also provides clues about dark matter, because the amount of bending depends on the total mass present, including mass that cannot be seen directly. By studying how light bends around galaxy clusters, astronomers can map the invisible halos of dark matter surrounding them, revealing structures that would otherwise remain completely hidden. Even the largest cosmic structures can act as lenses, enormous clusters of galaxies, bending light across distances of millions of light-years. Through these gentle distortions of light, the universe quietly reveals its invisible architecture. Across the vast darkness, light travels patiently for billions of years, weaving its way through curved space-time, passing near galaxies, drifting through clusters, and slowly crossing the expanding universe. And by the time that ancient light finally arrives at distant observers, it carries with it subtle traces of every gravitational curve it encountered along the way. Delicate signals that allow the strange physics of space to be seen through the quiet bending of light itself across the immense stillness of the cosmos. Across these vast distances where light bends and galaxies gather, the universe also reveals another quiet phenomenon: gentle waves moving through the very fabric of space-time itself. For centuries, gravity was understood as a force acting instantly across space, a silent pull between objects. Yet modern physics suggests something more subtle. When massive objects move or collide, they create ripples in space-time that travel outward across the universe. These ripples are known as gravitational waves. They move through space much like waves across the surface of water, spreading outward after a disturbance. Except these waves travel through the structure of space-time itself. When two massive objects orbit each other closely, such as a pair of neutron stars or black holes, their immense gravity begins to disturb the surrounding space-time, sending faint waves outward in every direction. For billions of years, these waves travel quietly through the cosmos, passing through galaxies, stars, and planets without being noticed. Even Earth itself is constantly being crossed by these gentle ripples, though their effects are incredibly small, stretching and compressing space by distances far smaller than the width of an atom. Detecting such tiny changes required instruments of extraordinary precision. Vast observatories designed to measure the most delicate movements imaginable. In the early 21st century, scientists finally observed these waves directly, confirming a prediction first suggested by Einstein many decades earlier. The signal came from two black holes orbiting each other in a distant galaxy, spiraling closer and closer together until they merged, releasing an enormous burst of gravitational energy. That event occurred more than 1 billion years ago, yet the waves from that collision continued traveling silently through the universe, eventually reaching Earth, where sensitive instruments recorded their passing. For a brief moment, humanity detected a faint tremor in space-time, a signal from two ancient black holes colliding far beyond our galaxy. Since then, several more gravitational wave events have been observed, each one revealing new information about the hidden dynamics of the universe. Through these observations, astronomers can study objects that produce little or no light, black holes merging in darkness, neutron stars colliding deep in distant galaxies. In this way, gravitational waves offer another method of observing the cosmos, not through light, but through the subtle vibrations of space-time itself. And across the silent expanse of the universe, these waves continue traveling endlessly, faint echoes of ancient cosmic events, moving quietly through galaxies, through stars, and through the vast darkness between them, carrying with them the hidden motions of the strange physics of space. Beyond the motion of galaxies, beyond the bending of light and the quiet ripples of gravitational waves, another layer of mystery surrounds the universe itself, the simple question of how it all began. When astronomers observe the most distant galaxies, they are looking far back into cosmic history. Light that has traveled across billions of years before reaching Earth, signals from a time when the universe was far younger than it is today. By studying this ancient light, scientists discovered that the universe was once much hotter, much denser, and far smaller than it appears now. Long ago, before galaxies formed, before stars ignited, the universe existed in an extremely energetic state, a vast, glowing ocean of particles and radiation moving rapidly in every direction. During those earliest moments, matter and energy were so tightly packed that light itself could not travel freely. Photons scattered constantly through dense plasma, unable to move far without colliding with charged particles. As the universe expanded and cooled, conditions slowly changed. After hundreds of thousands of years, matter and radiation began separating, allowing light to move freely across space for the first time. That ancient light still exists today, stretched and cooled by the expansion of the universe, now observed as a faint glow filling the entire cosmos, known as the cosmic microwave background. This quiet radiation forms a kind of fossil record of the early universe, a delicate snapshot of space at a time long before the first galaxies appeared. When astronomers mapped this ancient glow, they discovered tiny variations in temperature, extremely small fluctuations that once represented slightly denser regions of matter. Over billions of years, gravity slowly amplified these differences, pulling matter together into the first stars, the first galaxies, and eventually the immense cosmic structures seen today. In this way, the universe grew from subtle beginnings, minute variations expanding into enormous formations across space. Even now, the faint radiation of the cosmic microwave background surrounds every galaxy, every star, and every planet, quietly filling the entire universe with a whisper from its earliest age. And as the mind drifts calmly through these ancient origins, the universe begins to feel even more vast, a place where the light from its earliest moments still travels silently through space, carrying the memory of a time when the cosmos itself was only beginning to unfold across the deep and endless darkness. Across this observable universe, where light carries messages from ancient galaxies and the cosmic horizon marks the edge of what can be seen, another subtle question begins to emerge, one that has quietly puzzled astronomers for generations. The shape of the universe itself. At first glance, space appears endless and uniform. Stars scattered across the sky, galaxies spread through deep cosmic darkness. Yet on the largest scales, the geometry of the universe may follow certain patterns, gentle curves in the fabric of spacetime that extend across unimaginable distances. Just as the surface of the Earth curves smoothly across the horizon, space itself may possess its own geometry, shaped by the total amount of matter and energy contained within the universe. If the density of matter were high enough, gravity would slowly curve the universe inward, creating a cosmos where traveling far enough in one direction might eventually return to the starting point, much like circumnavigating a planet. If the density were lower, space could curve outward instead, expanding endlessly without forming a closed shape, stretching infinitely across the darkness. Careful measurements of distant galaxies, cosmic radiation, and the expansion of space suggest something even more subtle. The universe appears remarkably close to flat. In this context, flat does not mean empty or featureless, but rather that space-time follows a geometry where parallel paths remain parallel across immense distances, where the large-scale structure of the cosmos unfolds without noticeable curvature. This delicate balance between matter, and dark energy determines the overall geometry of the universe, shaping the way light travels across space and the way galaxies move within the expanding cosmic landscape. Even the faint glow of the cosmic microwave background, the ancient radiation left from the early universe, carries tiny patterns that reveal clues about this geometry. By studying these patterns, astronomers have been able to estimate the shape of the universe with remarkable precision, discovering that the cosmos appears astonishingly balanced, neither strongly curved inward nor outward. Across billions of light-years, space unfolds with quiet consistency, galaxies drifting slowly within an immense and nearly uniform cosmic fabric. And yet, despite this remarkable understanding, the true extent of the universe may remain forever beyond observation, stretching far beyond the cosmic horizon into regions no light has yet reached. Somewhere beyond those distant boundaries, the universe continues expanding quietly, galaxies forming, stars igniting, gravity shaping new cosmic structures across the endless dark. Within this vast geometry of spacetime, the strange physics of space continues unfolding, slowly, patiently, across billions of years. Beneath the silent glow of countless distant stars, within this vast and nearly balanced geometry of the universe, another quiet realization begins to appear, one that slowly changes how space itself is imagined. The understanding that emptiness is never truly empty. For a long time, the dark regions between galaxies were thought to be completely void, silent spaces where nothing existed. Yet modern physics reveals that even the deepest vacuum carries subtle energy within it. Across all of space, invisible quantum fields quietly fill the universe, delicate frameworks that exist everywhere at once, stretching through galaxies, stars, and the vast, empty voids between them. Within these fields, tiny fluctuations constantly appear and disappear, particles briefly forming before fading again, a restless activity occurring beneath what seems like perfect stillness. This quiet energy of empty space is sometimes called vacuum energy, a subtle property woven into the structure of the cosmos itself. Even where there are no stars, no planets, and no galaxies, the universe still carries this faint background activity, a quiet hum within the fabric of reality. These quantum fluctuations may seem incredibly small, yet across the enormous scale of the universe, their collective influence could be connected to the mysterious dark energy driving cosmic expansion. In this way, the deepest emptiness of space may still contain the seeds of motion, subtle energies shaping the long-term evolution of the cosmos. The universe, therefore, becomes something far more dynamic than simple emptiness. A vast field of gentle activity where invisible forces quietly guide the behavior of matter and energy across billions of years. Across these immense cosmic distances, the strange physics of space continues unfolding silently. Quantum fields vibrating softly, galaxies drifting through expanding space, and light traveling patiently across the dark. Far beyond individual galaxies, beyond the quiet influence of quantum fields and cosmic expansion, the universe itself continues evolving across unimaginable spans of time. Stars ignite, shine for millions or billions of years, and eventually fade, their material returning to space where new stars may one day form again. Galaxies slowly change their shapes, spiral arms stretching and bending, small galaxies merging with larger ones, gravity quietly reshaping cosmic structures across immense periods of time. Even our own Milky Way galaxy is part of this long cosmic story, drifting slowly through space within a small cluster of neighboring galaxies. Among them lies the Andromeda Galaxy, a vast spiral system moving gradually closer to the Milky Way across millions of years. The motion is slow and almost imperceptible, yet over immense stretches of time, these two great galaxies will eventually approach one another, their gravitational fields interacting, their stars passing through each other in a slow cosmic encounter. Such galactic mergers are common across the universe, quiet transformations where billions of stars shift their paths across millions of years. Yet despite these slow changes, the universe often appears calm and timeless. The night sky above Earth filled with steady points of light, distant stars shining gently across the darkness. Within that calm view, the deeper physics of space continues its patient work. Gravity shaping motion, quantum fields vibrating softly, and cosmic expansion gradually stretching the distances between galaxies. And through it all, the universe remains astonishingly vast, governed by laws that are both elegant and mysterious, unfolding slowly across billions of years in the silent ocean of space. Across this immense universe, where galaxies drift slowly through expanding space, another quiet realization begins to appear. The understanding that the cosmos moves on timescales far beyond ordinary human experience. On Earth, time is measured in days, seasons, and years. Cycles familiar to life on a small planet orbiting a single star. Yet in the larger universe, time unfolds across millions, billions, and even trillions of years. Stars themselves live astonishingly long lives. Our own sun, for example, will shine steadily for billions of years before it begins its final transformation, quietly expanding and releasing its outer layers back into space. Many stars are far older than our Sun. Some formed when the universe itself was still young, their light traveling across space long before Earth ever existed. These ancient stars drift quietly through the galaxy, carrying within them the chemical elements forged in earlier generations of stellar explosions. Elements that would eventually become planets, oceans, and living worlds. The atoms within every human body were once part of distant stars, formed in the intense heat of stellar interiors, scattered across space by supernova explosions billions of years ago. In this sense, the universe slowly recycles itself. Stars forming from clouds of gas, burning for immense spans of time, and eventually returning their material to the cosmic environment. From that recycled material, new stars appear, new planetary systems emerge, and the quiet cycle of cosmic evolution continues across the galaxy. Even galaxies themselves follow long lifetimes, growing slowly through mergers and gravitational interactions, their structures evolving over billions of years. The Milky Way, our home galaxy, has existed for more than 13 billion years, quietly rotating while hundreds of billions of stars move through its spiral arms. Within those arms, new stars continue to form today, glowing nurseries of gas and dust collapsing gently under gravity, giving birth to future suns that may shine for billions of years to come. Across the vast cosmic landscape, the universe remains patient, its greatest transformations unfolding slowly across unimaginable periods of time. And within that enormous calm, the strange physics of space continues shaping reality. Gravity guiding motion, time stretching quietly under the influence of massive objects, and light carrying messages across the deep darkness between galaxies. All of it moving forward, slowly, silently, across the endless ocean of the cosmos. And as this quiet journey through the strange physics of space slowly begins to settle, the universe itself seems to grow even calmer, stretching endlessly beyond every horizon of imagination. Across the immense darkness between galaxies, stars continue their patient burning, releasing gentle light into the surrounding void. Light that may travel for millions or even billions of years before reaching another distant world. Gravity continues its silent work, shaping the motion of planets, guiding the slow rotations of galaxies, and weaving the vast cosmic web that stretches across the universe. Deep within that web, black holes rest quietly at the centers of galaxies. Neutron stars spin slowly in the dark, and faint ripples of gravitational waves drift across space-time from ancient cosmic events. Even the most distant regions of the universe remain connected through the same delicate laws of physics: gravity bending space, light traveling across unimaginable distances, and time itself flowing differently wherever mass and motion reshape the fabric of space-time. Yet despite all these strange and powerful forces, the universe remains remarkably peaceful. Its greatest events unfolding across spans of time so vast that even entire civilizations pass like brief moments within the cosmic story. The stars above continue their slow and ancient dance, galaxies drifting gently through the expanding universe, while faint cosmic radiation carries whispers from the earliest moments of creation. And somewhere within this immense cosmic ocean, a small blue planet quietly orbits an ordinary star, surrounded by the same mysterious laws that shape every corner of the universe. Here, beneath the soft glow of the night sky, the strange physics of space becomes something more than distant theory. It becomes a reminder of how vast and beautiful the cosmos truly is. And as the light fades, the silence becomes absolute. Tonight, you have drifted through the mysteries, absorbed the peace, and understood the ancient rhythm of the cosmos. Remember that the universe is always holding you, a constant, silent anchor. Rest now, deeply, sleep well, and I look forward to guiding you again through the physics of the dark. Good night.